instance. So a replica of the data is going to be written on a block on a server in Apapa. That server is on a rack in Apapa. Then there's another rack inside that same server room in Apapa. Another replica is going to be written to that second rack within the server room in Apapa. Now, there's a remote location. Ojota switch room is a remote location to Apapa. So another replica can be written to another rack that is in Ojota. And why that is so is that there could be a fire incident. There could be a power incident in the whole of Apapa switch room in such a way that everything in Apapa may no longer be accessible at that particular point in time. So automatically, Hadoop or HDFS is just going to switch to the replica that is in Ojota, or Ojota switch room. Then it now sends an additional replica to a random location that could be local, maybe in Apapa switch room, or that could be in a remote location, which could be Ojota switch room or maybe Abuja switch room. So you just send another replica to another random location just in case, and it tracks all of that. There is a component in Hadoop that tracks all of that. But for the data block in this case, what tracks all of that is going to be the name node. The name node tracks all of those different replicas and the location where they are stored, so that if there is no longer heartbeat between any of these replicas and the data and the name node, automatically a replica is there's a switch to a replica. So all of this is essentially to guarantee high availability, is to be able to guarantee that there is no one single point of failure, which is very, very important. There's no single point of failure. So a rack, a commodity server can go down. So because of that, we are not going to just store our file on a single commodity server. Then, so within the same server room, we are going to store the data on multiple commodity servers, one on rack 1, another one on rack 2. But the server room itself can go down. Maybe there is fire incidents or there is no network access, which still makes it a single point of failure. So because of that, we throw another version or replica of that data to a remote location, So that guarantees or that guards against a single point of failure. And also the same is also applicable. The way it happens for data nodes, it also happens the same way for name node. So if the name node cluster was not active, HDFS would not be available. As we have said in the past, name node is like the address book that has information about every other data that is in the cluster. So a replica of name node 2 is created. So a replica of that address book is created in such a way that it guarantees total availability. So you can imagine how complex that Hadoop system is going to be, and how the tracking of all of this is to track all of that, how it's going to be. It's definitely going to require a whole lot of programming at the back end. Okay, thank you for accepting that user into the class. I think Adebayo also joined the class. Welcome to the class, Adebayo. So, but all of that is just like a revision of what we have done on MapReduce before. So it's just like a recap that should add more to the knowledge that you have already had. So this evening, we are going to be spending more time on those things that we've not talked about. So let's look at MapReduce. If we have talked about MapReduce before, we'll just talk about it in some more details. MapReduce, it's not like a software like that. It's an algorithm. So it's an implementation algorithm that is of course, implemented by Apache Hadoop project. It's part of the Apache Hadoop project, and it works like an engine. It's like an engine, and that is also how it works. Because if you fuel it, you fuel it with data. Once you fuel MapReduce with data, it gives you an output, like in terms of that output, the way you have an engine that you put fuel in an engine and it makes the wheel to start working. So when you want to analyze data, when you want to perform some operation on data, you apply MapReduce on that data set, and then it gives you the results that you want from the data, and it brings it out. It's very, very efficient, and it runs very, very quickly. The MapReduce applies the concept of parallel programming. Remember, HDFS employs the concept of distributed computing and parallel computing, or Hadoop employs the concept of distributed computing and parallel computing. So HDFS also employs that same concept. So it was popularized by Google, and it's used to simplify data processing across massive data sets. Just imagine your email. My email, I've had like a Gmail account since like maybe 2006, for instance. And if you want to go and search email that someone sent to you as far back as 2006, just go to your Google and do a Google search. It brings it out. Then if you wonder what is happening at the back end, how is this data stored, that is able to bring out my data as fast, as quickly as possible. Or is the concept of MapReduce that it's actually working at the back end. So MapReduce includes several stages. There is the map component of MapReduce. There is the reduce component of MapReduce, and the way it works is that when the user submits a job, to a Hadoop system, the two primary components of MapReduce, the map and the reduce, breaks that data down. Let me take that again. Let me take that again. And one way I can easily explain MapReduce is by differentiating it. I like to differentiate it with relational database system. So if you have a big job that you want to do, or you have a very big file, that file, I gave the example of MTN big file, for instance. For that file, first of all, that file has to be loaded into a database before you can start performing operation on it. So if the file is so huge, it's going to take a lot of time. Maybe it could take maybe 30 minutes, 1 hour in order for you to be able to, sometimes more than that. It could take up to 7 hours to load some file. It could take more than 24 hours to load some type of files. So you need to load that file into a relational database, and then you now start performing whatever operation you intend to perform on that file. So if you want to sort the content of that file, for instance, you run an order by command that sorts that file in a particular order and gives you the result. But that sort operation that you are performing within a database, you can actually perform it on the file itself, and that is what MapReduce helps you to do. So MapReduce can help you to sort what you have in a file, without necessarily loading it into a database. So for you to be able to achieve that, once you submit the job, it starts a MapReduce program that breaks down that file into smaller bits. It breaks down the file into smaller bits. Remember, the file will be loaded on HDFS. So MapReduce will now break that file into smaller bits, and then the MapReduce program will now run. In this case, it's sorting that we want to do. It will now sort each component of the smaller bit. It will sort each component of the smaller bit, and then combines the results all over again and present the answer. It's in a recursive way. It runs it in a recursive manner. But because of the fact that it's doing it on smaller chunks of data, it makes it it gets it done faster and in a more efficient way, and you get your results faster than you having to load the data into a relational database and then running the command and then exporting the result all together again. So that is like a very practical example of how MapReduce work. I'm going to pause a bit just to be able to take comments. If there are comments, if there are questions about MapReduce, please feel free to ask me. Let me ask someone. Emmanuel, do you have any question at this point? Hello, Emmanuel.
No, I don't have.
Okay, thanks. So one of the strengths of MapReduce is that um, it works on test data. It can work on test data. It can work on machine generated logs. It can work on sensor data. It can work on images. It can work on pictures, and it gets the job done as quickly as possible and in a very efficient way without you. It's a major advantage that you don't have to do that loading of the data into a relational database system. You know, that is a huge advantage of MapReduce over the traditional database system. There are times that we want to do some job, you have a file, you want to do maybe a basic count. You just want to count. You want to count the number of records. You might spend like 7 hours to first of all load the content of that file into a database before you can run a count command. But with MapReduce, you can simply count without necessarily having to load the file. So what it does is that if the file is broken down into smaller chunks, it counts the records in each of those chunks and then combines the results. It's a very simple implementation. So it's a very simple implementation. So this picture, it's a graphical representation of how MapReduce takes a job from a user. So MapReduce takes a job from a user and then reads it into HDFS. So that file is logically stored on HDFS. Remember, last week we did copy from local to HDFS. So what is going to be happening is that maybe this is the local machine, this film or this file is copied from the local machine into HDFS. Once it's copied into HDFS, a MapReduce program splits the content of that file using the map function. It reads it and uses the map function to partition the file into smaller bits. And the example that I gave of sorting or counting the record in the file, it does a sorting of every split that it has created, and then or it does the counting, it does the sorting or the counting of every split it has created, and then the reduce function now combines the results together to give you an output, and that output is written back from HDFS into your it's written back from HDFS into your own computer, your local computer, so that you'll be able to access the file. So what this does is that compared to relational database management system, what this does is that it saves the time of having to start loading the file, reading the file into a database system, which can take a whole lot of time, you know. So now MapReduce has some disadvantages, of course, and it also has some advantages. So in terms of disadvantage, MapReduce is not a database. So it's not a database. So the file, you just read the file into the file system just like that. So it may not necessarily require a specific database user login. It may not require all the type of security and the features that you have, the indexing features that you have in a relational database. MapReduce come with the responsibility of you having to define what type of data that you are working on. So if you are working on text data, you might have to define that this is text data. If you are working on number data, you might have to define that this is number data. If you are working on pictures, you might have to define the data structure. If you are working on a list, there are some other type of data structure like a list or a graph or what have you. So all of that you might have to specifically define the type of data structure that you are working on, which adds some extra constraints on you as a data scientist. MapReduce considers every job as an entity in itself, and is not aware of other processes that is running. So in a relational database system, if you are running a query, for instance, that query can enter a deadlock, or there can be what is called, it can enter a lock, because a query that you are running is aware that another query is running. If you are running an update statement, for instance, that update statement is aware that other users are also accessing. They are also accessing that particular file, and because they are aware they are accessing that file, you will probably have to hold on or have to sequence that operation in such a way that the person that is writing finishes writing before the person that is reading can read. You understand? But for HDFS, it's not aware of any other operation that is running. It runs without that knowledge, and it could be a disadvantage. Disadvantage in the sense that while somebody is trying to write to a file, and another person is reading that file, you understand? The person that is reading that file, it may not be exactly what is reading from the file that he's expecting. Maybe what the updated version is what he wants, what he's expecting. Let me find another way of explaining that. So MapReduce is not aware of any other operation that is running. He just gets his own job done without being aware of what is happening, other process that is running simultaneously. So what that means is that, say I'm writing to, okay, so say I want to check my account balance. Let me give this very, very simple example that a lot of people can relate with, because of course, I like money, so let me use money example. So if a MapReduce program is maybe updating an account balance, for instance, it's updating an account balance, and somebody is trying to query that account balance, at times the way it is that the process that is querying that account it's also aware that there's a process that is updating that account. So you might have to wait for the process that's updating that account to complete before it displays what the account balance is, But in MapReduce, they are both not aware of each other. The one that wants to read the account balance will just go and read the account balance without being aware that there's a process that is currently updating that account balance. So that is a very, very simplified example of one disadvantage of MapReduce. But in terms of strength, I've given some of the strengths. The fact that it can save a whole lot of time without you having to start loading data into database, and it can help you to selectively extract. You can selectively extract what is in the big file. So you have a big file, you only want to extract the component of that file. MapReduce can help you to do that seamlessly. Can help you to do that seamlessly. If MapReduce can help you to extract the process output of a file. So in a relational database system, if you want to load data, if you want to process a data, for example, you need to first of all load it. But with MapReduce, you can extract an aggregated version or a processed version of that file. So you can process a file within MapReduce, and the output will be what you are loading. So that can also be a whole lot of advantage for the data engineer that is working on that data. So those are the advantages of and disadvantages of MapReduce. Then, so I've talked about this. MapReduce is not a database, it doesn't have the features of a database. It considers every job as an entity, so it's not aware of everything around it. It defines, you need to define the type of data that you're working with, and it's a relatively new concept. So it's not a lot of people that know how to like program MapReduce. Okay, so that is that on MapReduce. Please, if you have any question, feel free to stop me at any time to ask your question. So next, we are going to be talking about yarn. So, which is the third, yarn is the third core component of the Hadoop ecosystem, and it comprises of two key components: the global resource manager and the peer application manager. So historically there is Hadoop version 1 and there is Hadoop version 2. So before it was MapReduce that was actually doing the work of yarn in Hadoop version 1. And what it does is that it tracks all the different resources that are available within the cluster. So you need something that will track all the processes, all the resources that are available within the cluster. This is available in the cluster. Data block is available in the cluster. Commodity server is available in the cluster. Memory is available in the cluster. Disk space is available in the cluster. Processing power is available in the cluster. So it was Hadoop that was managing all of that before. No, it was MapReduce that was managing all of that before. Please pardon me. So it has to schedule, it has like a scheduler. So if like 4 different processes need access to a particular resource, maybe they need access to a processor, for instance, it is that resource manager that would need to assign the processor to whatever application that needs it. So when you look at it, for MapReduce, it became a whole lot of work as the system expanded a lot. It became a whole lot of work for MapReduce to be able to handle. So because of that, they now had to develop another component which is called yarn, yet another resource negotiator, to be able to manage all those housekeeping jobs that is required within the Hadoop system. So let me paint it in a different picture. So imagine there is an event. So like a party. Imagine there is a party. So in that party, you have ushers, you have security men, and then you also have bouncers. So what yarn does is that yarn it's that component. It's like the usher that will say, okay, this space is available, go and sit down on this chair. This table is available. How many of you guys are coming? 4 of you guys are coming. Around this table you have space for 4 people, so 4 of you come and sit down here and stuff like that. But before yarn was created, so imagine is the security guys that tell people where the car should park. They're also the people that will go inside the hall to tell people where to sit down inside the hall after they finish parking them outside. So you can imagine it's going to be a whole lot of work in that scenario. So because of that, they now created another resource manager, or another resource negotiator, which handles the coordination of all the different resources that you have within the Hadoop cluster. So as I said, you have the global resource manager, which is also called resource manager. You also have the application master, which is called the which function is for application management. So there is one that manages applications that are running on the cluster, and there is one that manages the resources that run on the cluster. So the resource manager is like the master controller. It's like a master controller within the Hadoop within the Hadoop framework. It's a scheduler. When they say scheduler, it's one that assigns that, okay, you can use the processor for this amount of time. You can use the disk space for this amount of time. You can use the network for this amount of time. You'll be able to use the memory for this amount of time. So it schedules job to be able to use all the resources that are available. So it assigns tasks to the system resources to run within a specific time, and then it monitors them to so you can say that you run for 30 seconds or you run for 30 milliseconds, and you finish running for 30 milliseconds, it removes it and allow another process to run within its own time frame. The way it works is that it manages the CPU, the disk, the network, and every other important resources that are required for running any application. While you now have the application manager. The application manager notifies the resource manager. So what application manager does is that it also provides information about the different applications that are running, the type of resources that those applications that they need in order to be able to execute optimally. So it provides information so application manager provides information to resource manager in order to be able to ensure that an application runs properly. And that is the whole information about Yarn. And most of the time, I think the job that the data scientist will probably need to do is just to start the Yarn, just start the process and leave it. In the algorithm inside it already knows how to schedule the job. It's not like you manually schedule the job as a data scientist working on the data. If there's any question you have on the core components of HDFS, please feel free to ask me before we now move to the other components that are not core components of HDFS. So if you have any question on Yarn, on MapReduce, on HDFS, please feel free to ask. Okay, so with the silence, I'm assuming that there are no questions. So let's move on to other components of the Hadoop system that is not part of the core component. So we are going to be talking about HBase and Hive and Scoop and Pig Latin and Flume and Pose and Zookeeper. So it's more or less like saying I think it's not voluminous. It's just some very simple things. Later on in the course, we are going to also be trying our hands on some of these components like Hive, like HBase. The guys that are doing engineering are going to be practicing Scoop and Zookeeper and Flume. So welcome on board. So this is part 2 of today's class. So let's start with HBase. HBase it's a Hadoop application that is used for real-time read-write access to large volume of data, or when large volume of data is required. HBase is that Hadoop application that handles the read-write random access. Read-write random access. So read-write random access is different from one question you may want to ask is, okay, so I'll ask a question. After explaining this, I'll ask a question. I'll ask a question after explaining all of this. So Hate-based is distributed, but it's not relational. And what does that mean? When they say hate-based is distributed, distributed means that the data on hate-based can be distributed across multiple systems. So you can have 4 computers connected in a cluster, and then hate-based, the data on hate-based can be distributed on the data on a hate-base. Let me put it that way to simplify it. The data on a hate-based database can be distributed across all of those 4 computer systems. It's also popularized by Google, and it's modeled after what Google call the Google Big Table. It's not relational. It's not relational, but it's very, very efficient. So how your email is stored, how our email is stored is not relational. How our email is stored is not relational, but it's very, very efficient with that. We extract emails from the email application itself. So it's H-based. It's one of those things that help you to be able to achieve that. The same way with WhatsApp. WhatsApp H-based is that component that is running at the back end of WhatsApp that makes WhatsApp easy to retrieve. You can easily search through WhatsApp to retrieve chats that people have sent to you on a particular topic many long time ago. So hate-based is distributed, it's non-relational, and it's modeled after the Google Big Table. So how it works is it works the way a relational database works. So you can just simply load your data into a hate-based application, and it's just as simple as that. But the only thing is that it does not have referential integrity. So in relational database system, you can say, I have one account number. So with that account number, I want to check all the transactions generated by that account number. In HBase, it does not work that way. You know, HBase is just one column. It's just like one column. Everything is just stored. It's just stored away into a single table. And the implementation of HBase offers a lot of useful features for data processing. It is scalable. It supports multi-dimensional kind of data set. There are data sets that are multi-dimensional in nature. So HBase can support multi-dimensional data sets. And then when your big table implementation require real-time random access read-write, HBase is a very good solution. So some of the characteristics of HBase is consistency, of course. With relational database system, so you can also have some level of consistency. But HBase provides a lot of consistency with your data, because when you need referential integrity at some point, the data might not become inconsistent or become stale when the primary key is deleted and every associated data is not deleted. So the customer has closed his account. Everything the customer has generated needs to be purged from the system because the customer is no longer a customer. But in relational database, the other data generated by that customer is still going to be there. But for HBase, once that customer is deleted, or once that stuff that's supposed to be the primary entity, once that is deleted, every other thing goes. So it provides, it allows for consistency of data. Then it has a functionality that is called sharding. So HBase offers transparent, automatic splitting and redistribution of its content. So if the content becomes filled up, automatically it splits. It does like a spillover of its content. It redistributes its content so that the data can easily be distributed across the file system. That process is called sharding. It guarantees high availability. Anything that is within a distributed system, there is always high availability. So high availability is guaranteed. The same is guaranteed with HDFS. HDFS also guarantees high availability, and it's programmatically accessible. What that means is that you can write programs that will access the content of HBase. So it's programmatically accessible. You can write a Java program, a Python program, or R program to access the content of HBase. And it also supports different type of IT operations like incremental data gathering, real-time information exchange, and frequently changing the um, frequently changing content serving. So what that means is that the content of HBase can change constantly. HBase allow that functionality to be able to manage that frequent changing of the content of his data. And the way it does it is that he use timestamp to be able to track all the changes that are happening within it. It's also very simple. It has a set of commands. Let me just quickly do a Google search. HBase command. Commands. So HBase command. So if you are able to set up HBase on your system, or maybe if you're able to set up a Hadoop cluster and you're able to set up HBase on your system, there are just a few set of commands that you might need to run. So you can see create table, list all the tables in HBase, disable a table so that it's no longer accessible, enable a table. Is disable is to check whether a table is disabled, describe the content of a table, alter a table, if a table exists, drop a table. You can see simple functions, very simple functions. And these are data definition command. Then you can also have a Java API that access the content of that data. Then you also have some data manipulation command like put. When you put a cell in a specified column, when you fetch the content, when you delete the content, when you delete all the content, when you scan, you can see they are very very simple commands. So you can become a HBase expert in one single day. You can be a HBase expert in one single day. These are all the commands that are available within HBase, at least for version 2 of Hadoop. These are the list of commands. So you can see for if you are using HBase for whatever command you want to perform, you can simply use these commands to do the data manipulation and these commands to do the data definition. Simple, very simple stuff. Very simple stuff. And that ends HBase. So you can see that it's very simple. It's just for you to practice it. So that ends HBase. So I want to ask any question.
I have a clarification.
Okay, please go on.
Okay, so when we're talking about HBase, you said it's not a relational database.
Yes.
Okay, but can you go back 2 slides? Okay, so the first one that is orange.
Yes, it's a columnar database that enables all data to be stored into a table in rows and columns, similar to RDBMS. And the intersection of a row and column is called cell. Yes.
Okay. So the question is, so in HBase, data is stored in rows and columns. It's just that it's not a relational database.
Yes.
Okay. I think that clarifies it, because I was thinking in my head, so relational database is all these databases where you have a primary key here, a foreign key, where the tables are linked to each other, maybe by virtue of a key, right?
Exactly.
Okay, no problem. Thanks.
So thank you for bringing up that. So so most times we normally think that everything that is rows and column, ordinarily you want to think that okay, maybe it's a database, yes, but some databases are not relational. They are not relational. When they say they are not relational, it means that you cannot relate what is in maybe one table to what is in another table. You know, so the implementation of H-base does not allow that kind of relationship. You know, if however, it's achievable. That does not mean it's not achievable. But if you want to achieve that, you need to use program. You need to write another program to be able to achieve that within the implementation of the H-based database itself. That is not achievable. So you can write. So let me explain it for some other people that may not get that concept. So you can have a table, and that table has maybe a number of, okay, so you have employee table. Employee table has all the employee IDs and the employee first name and the employee last name. Then you now have the department table. So in the department table, you cannot have anybody that belongs to a department that is not an employee. You know, if you want to insert somebody into department table, if that person does not have an employee ID, it's going to generate error. You can have that implementation within a relational database system, but you cannot have that type of implementation within H-base. You cannot have that implementation within H-base because the table, employee table and department table, if they are in H-base, they cannot relate with each other. So it's not a relational database system. Rather, it's a what's it called? It's a columnar database, just like a big flat table. What some people call a flat table, it's just like a big flat table. Yeah, so that adds additional deep flesh to that explanation of H-base. Thank you, Ekwi, for bringing up that. So the question I want to ask is that what is the difference between H-base and HDFS? I know that both of them start with H. So don't say that the difference is one has base and the other one has DFS. That is not the difference I'm looking for. What is the difference between H-base and HDFS? That is my question. Who can answer that for us? Let's see everyone that is in the class. What is the difference between H-base and HDFS?
Okay, let me just make an attempt. I might not be entirely right. Okay, so to my own understanding, I feel H-base is just like a database that stores information or records of.
Louder, your voice is not clear.
Yes, H-base stores records and information. It's like a database. So let me take it that it's a database that stores records and information about any information. Whereas HDFS, what is the other one? The other component is like a storage, not a database in this sense, a storage that stores information like the whole application storage, just like the hard disk of your system, something like that. So that's the little understanding. I hope. Okay, that's all.
Okay, thank you. I'm impressed with the fact that this is your first day in the class and you're able to make that attempt. I'm impressed. Which is a good one, and that is a very good one for you. So I want to hear other people's explanation of the difference between H-base and HDFS.
Will this be counted as a difference that the HDFS is one of the core components of the Hadoop system? But this is
No, that is not it. No. Yes, it's a difference, but no, that's not what we are looking for.
looking for. Okay. So basically, I was going to say what she has said, where HDFS is a storage, is a logical storage for information within the Hadoop ecosystem, but the database part of it is the HBase. So outside of that, nothing else comes to mind.
So I agree with two of you guys. So you got it actually. So HBase is like an application. It's like an application like something like maybe Excel, like another type of Excel application. So you understand? It's like a database application. Why HDFS is a file system. It's like a logical location. It's like a location where you store file on Hadoop. So it's like a file system location. Like I'm storing my file on C drive, or I'm storing my file on desktop. I'm storing my file on my document. That is similar to what HDFS is. But HBase is similar to something like Excel or something like Microsoft Access or something like Oracle, like a database application that holds data and organizes data in a structured way. Thank you for those attempts. You definitely did got it. So there's another database. Now this database is a relational database. It's a relational database, and it's called Hive. It's called Hive. So Hive is a batch-oriented data warehouse. You can use Hive to develop a data warehouse for Hadoop, and it provides SQL-like commands. So the way you have SQL, they can write SQL commands. Select star from. Hive also have that SQL-like implementation without sacrificing all the different functionalities of the Hadoop framework itself, or the core component of Hadoop framework that require MapReduce, Yarn, and HDFS. And so what Hive does is that it's like a combination of SQL with MapReduce joined together to facilitate data analysis. So it's like a combination of SQL and MapReduce put together. Remember what MapReduce does? It does divide and conquer. It does divide and perform operation and combines the results together and present it to user. Now, you now imagine you are now able to do that kind of operation within an SQL environment. So that adds another level of efficiency to the type of data analysis that you can perform. So you have so in Hive you have tables, you have partitions, you have buckets. I love partitions. Partitions make my life very easy. Those days when I used to code, a lot of people now have made it possible for me not to be able to code the way I used to code before. But partitions, the way it is that so let's look at MTN. I gave MTN an example. So MTN has like maybe 50 million customers or 70 million customers. 50 million of them make calls in one single day. So if one particular customer generates 5 calls in a day, for instance, both receive and initiate and receive, that would be like 500 million. That is like 250 million rows. If only 50 million make calls in one day, that's like 250 million rows. Now, imagine you now want to query. Now, they've been keeping all of that data for the past 1 year, 250 million rows in a day, and they've kept that for like 365 days, or even more than 365 days. MTN has been in operation since 2002 or thereabout, 2002. So they've been aggregating all of that data for many years. Now we want to now query that kind of a database. You will now imagine you just run a single query. If you run that query, you just need to go and sleep. You run the query, you now remember, oh, I've not had lunch, oh, you go and have your lunch. When you come back, you see, the query is still running. You now go back again to go and do something else. You come back. In fact, there are times that there are queries that you run Friday evening. You run a query Friday evening. You'll be waiting to come on a Monday morning before you can see the result. Because the table is just so big. What partition does is that partition will help you to run your query against a small fraction of what is on the table. So instead of running the table, so imagine the data, and what you need is maybe the data for 2021 alone. A table can be partitioned by year, can be partitioned by date, can be partitioned by some keywords. You can use some keywords to partition those tables, and you can use some keywords to partition the table in such a way that when you want to query anything you want to query, you can use that keyword in order to be able to search what you are looking for. So in a case where you now want to query a table, the same example, you want to query that table for just 2021, you can give that instruction to hide that, see, for this query that I want to run, I want you to run it only, I want you to run it against 2021 partition alone, not the entire database from 2002 that MTN has been in operation till today, because that would be too much for me. But I just wanted to run it against the 2021 partition. So that is one functionality of partition. Then there is also bucket, which is another division. A table can still be divided into buckets in such a way that buckets are stored files in the partition directory, and buckets are based on a hash on the table. So bucket is like another level of partition, So you can partition, you can divide the table by partitions, you can divide table by bucket. And why that is so is that, remember, the data itself, the high data is on the table, but the real data, the raw data is sitting on a file. Even Oracle has it. Oracle has a data file. SQL Server has a data file that is .dbf. Oracle has its own data file. I've forgotten the extension for its data file. The same way, Hive too will have its own data file, and its own data file is going to be on HDFS. So you can create bucket and make it in such a way that when you are going to be running, when you are running this query, run it against the file that is on this particular partition on the file system. So bucket is the one that defines the file system. The bucket defines the division on the file system where your query is run against, while partition is defines the partition defines the division on the table where your query is run against. I hope it makes sense, but it's definitely going to make sense if you have. Say that again.
I don't understand the difference in the partition and the bucket.
It's actually very simple. Let me find the very simple of demonstrating this. Excel.xls. Let me look for very large file. My computer. Okay, so how can I demonstrate? Okay, so tables. So let me Excel. I want to find a way of explaining it, but it's just very simple. So let's look at this. Congratulations. My class is still on. Congratulations. But don't go yet. Don't go yet, Ashley. Don't go yet. I'm just trying to demonstrate something. So when I say don't go yet, stay around. Okay. Okay, so let's say this is partition. Okay, so this is just to simplify it. This is just to simplify it. So let's assume this is a table. Hey, can you hear me?
Yes, I am.
Okay, great. So let's assume this is a table. So this table has names of different people. So if you want to like write a simple SQL command, for instance, you can write something like select first name from table name, table name, for instance. So this is going to run. Okay, let's add a where clause. Where first name starts with letter A. So I want to make my screen bigger. 20. Okay. So just take a look at this. So here I have a table. Here. This is the table. It's a very big table. Let's assume it's a very big table. So I want to select first name from last name. I want to select all the first names from this table where the first name starts with A. So what happens is that if I have 200 million records here, or if I have, let's say I have, Facebook has 1 billion people on it. So say I have 1 billion people on this table, for instance. This my query is going to scan through the first element to the 1 billionth element to return everybody whose first name starts with A. So you can imagine that is going to take a very long time to execute. So because of that, they now implemented a functionality that is called partition. And they create it in such a way that if partition is created on first name, on first name, for instance, if it is created by first name, what it means is that everything that starts with A, every first name that starts with A will be stored on a different partition on the table. So the table can have different partitions. Are you with me? So a table can have, okay, so let me quickly meet. This is done in a different way. Meet this and I need 1. And then I want it to end. Yes. So I paste it. Now, so if then I'll go and sort this. No. Sort by column. Let me just sort it by by. Okay, so great. So now, so this is a table. This is not a column, this is not another column. This is a partition. So this is a partition, and this table is partitioned based on first name. And what's the essence of this partition? The essence of this partition is that anybody whose name starts with letter A is going to be stored in this partition. Is going to be stored in partition A. Anybody whose name starts with M is going to be stored in partition M. So there, why is that useful is that whenever you are searching, so when data becomes very, very big and you want to search through the database, so that you want, in order to avoid scanning through the entire data set, because scanning through the entire data set is going to take a long time, you can give instruction to the computer that, see, this data that I'm looking for, only search for it in a particular partition. But of course, the partition would have been predefined. It could be predefined based on maybe a string, like maybe the first character of a first name. It can be predefined based on the year. It can be predefined based on the month. It can be predefined based on the day of a year. It can be predefined based on that. So now, if you look at this query, so this is a query that says select first name from last name, where first name starts with A. If the table is not partitioned, or even if the table is partitioned, if you write the query this way, this is going to scan through the entire table, no matter how much the number of records that you have in the table. Maybe it's 1 billion or more than 1 billion. As much as it is going to scan through everything and then return the results. That is going to take a very long time. But when you have a partition, you cannot include a function like partition. You cannot include a command partition A, partition file first name. You can include something like partition first name A, and there will be partition first name B, and there will be partition first name C, and there will be partition first name D. So when you do this, instead of this query to scan through the entire table, it's only going to scan through the partition that you have specified. So that is going to significantly reduce the amount of time it will take for the query to run. Remember, we are dealing with big data here. So with partition, you can reduce the time it takes to run your query. Now that explains partition. Now again, even though this data is on a database, it's still going to be saved, or there is still going to generate what is called a data file. And that data file is going to be stored on Hadoop. It's going to be stored on HDFS, So it's going to generate a data file, and that data file is going to be on HDFS. So with buckets, remember, we are talking about partitions and buckets. With buckets, you can now also specify exactly which bucket to find the data that you're looking for. So the data will also be divided into buckets in such a way that you can specify partition C, bucket 2021. So maybe each year has different buckets. There is the 2020 bucket, there is 2019 bucket, 2018 bucket, there is the 2021 bucket. Now we are looking for everybody whose name starts with A, and you are looking for them in partition. You are looking for them in partition first name A, and you are looking for them in bucket 2021. So it does not have to scan through the entire data set that you have always stored away. It only looks for them in specific location. Now, when you are specifying your location where to find the file, whether on the table or on the file system, it makes your query execute faster. So this first name is specifying the location on the table where you can find the data that you want to run, or where you can get the result of the query you are running. This is specifying the location on HDFS where you can find the data that you are trying to run. That is the function of partition and bucket within the Hive within the Hive database. Does it make sense? Or is it not very clear?
So is it right or wrong to say that, maybe not in exact terms, but a bucket is a subset of a partition?
So a bucket is not so it depends on the implementation.
Yes. Okay. A bucket can be a subset of a partition.
Yes.
Okay.
A subset can be a bucket can be a subset of a partition, but it needs not to be so. In fact, there can be tables without partition, but there can be buckets. So there can be buckets without partition. There can be partition without bucket. And bucket can be implemented in such a way that it can be a subset of a partition.
Okay. Okay, thanks. I get it.
Thank you for drilling me. Okay, so there are a few questions here. The answers are already there. Which of the following components of Hadoop provide SQL-like access? Of course, it's Hive. Hive provide SQL-like access, while HBase provide columnar read-write access to the file. You can also go and check. Hive commands. Also go and check Hive commands. So for those that are conversant with SQL, these are Hive commands. So you can create table, you can drop table, you can truncate table, you can alter table, you can describe a table. There are different commands. You can put comments on a table. You can provide the location paths on a table. The location path on that table is like defining the bucket of that table. You can define a table with some DB properties, and you can drop a table and so on and so forth. There are different commands. So the same way you have data definition, the data definition language and data manipulation language, you also have all of that in Hive. So you can always reference materials online. But it's also in the textbook. For the guys that are doing engineering, some of those commands are there in the textbook. So let me move to pig. So please don't be so there are they just come up with those names. Maybe after they finish developing the tool, they just look around, whatever they see, they just use it to name whatever tool that they have developed. So we heard about Hive, maybe there were bees, they were flying around. You heard about HBase, or you heard about Zookeeper or Pig or Scoop. You know, anything they just see around. You even see things like R or Python. You know, those names just pop up. There is no rationale behind the naming of this tool. So pig. Let's talk about pig. It's a scripting language. It's a scripting language. So for those that have developed a website before, if you built a website before, maybe you use PHP to develop that website. Pig is like that programming language. It's a programming language. You know, it's a programming language that is, but is specifically created or is specifically designed to define data pipelines. It's a programming language that is created for defining data pipelines or for expressing data flows. You know, that is what pig is. That is what pig is used for. But it's a scripting language that can be used by both developers and non-developers. If you also check pig Latin command, they are very simple commands that you can also learn. And when I say you can learn it in a day, it actually means it's very simple. You can see join command, distinct command. So but it comes in form of a programming language. It comes in form of a programming language. Very simple language for defining data pipelines, so you have command, load, store for each, which is like a loop. You have filter, you have group, you have join, you have order. Order is for sorting. You have distinct for looking for uniqueness in record. You have union, you have split. You can see all those commands, they are not much. We've not even had a case where you have up to 50 commands, whether for HBase or for Hive or for pig. So there are things that you can simply master in one single day. So you have pig, and pig Latin. They have rich syntaxes that you can use to perform different operations, like maybe you want to load data, or you want to stream a data, you want to filter a data, or you want to group a data or sort a data or combine data. All of those functionalities, they exist in pig. So yes, I think I'm in the right place. Yeah. So, and that is the end of pig. It's just a programming language. It's an easy to use programming language. In this course, we are going to be teaching more of our programming language, but of course, with that background knowledge, you will be able to like code any other programming language that you might need to learn in order to get your job done, as long as you have a reference material by your side. So we also have Scoop. Scoop is used for data migration. So if you want to move data from Hadoop, maybe you want to move data from Hadoop to Oracle SQL, or you want to move data from HDFS to Hive. You want to move data from Hive to MySQL or Microsoft SQL Server. Scoop is that tool that offers the ETL functionality, extract, transform, and load functionality for moving data from one system or from one database to another database. And it's a simple tool. It does bulk import. If you want to import large amount of data, if you want to you want to be selective. If you also want to be selective in the kind of data that you want to move, Scoop can import SQL for relational database directly into Hive or a HBase system. So you can move data directly from Oracle into Hive. So there are many ways. You might want to say what you have on Oracle. You want to first of all export it to a file. Then the exported file, you now move it into your local machine, and from your local machine, you can now transport from the local machine into. So you may want to export from me. Okay, so I missed my thoughts there. So say you want to move data from Oracle, for instance, to Hive. There are two ways you can go about it. You may first of all decide to say you export that data from Oracle into a text file or a CSV file. Then you now copy that CSV file into another computer, for instance, and then you now use your copy from local command that we did in HDFS and copy that file into a HDFS platform, and then from HDFS you have it loaded into Hive. That is one way. That's one way you can do it, but you can also do it without having to go through all of those stress. And for you not to go through all of that stress, you can use Scoop to grow. You just establish a connectivity between the source system and the destination system. The destination system can be Hive. The destination system can be HBase. then you just provide that connectivity, and then it extracts data from Oracle and it loads it directly into Hive. That is direct input. There can be data interaction where you can use a program to selectively extract the type of data that you want. Then you can also have data export. You can also use Scoop to export what you have on HDFS into relational database. So maybe you want to go from HDFS. On HDFS, there's a file system on HDFS. You want to export what you have on that file system into a relational database like Oracle. The data export functionality can help you to achieve that. They are all simple. They are all simple stuff. You can also Google that Scoop commands. So for Scoop commands, so for Scoop commands here you can find some interesting data migration commands. So first of all, is to be able to establish connectivity. Number two is to specify the username, and this is to specify the password. This is to specify the table. This is how you intend to split the columns in the table before you start loading it. This is to the target HDFS destination. Remember, I said here that you may decide to move into HDFS, and you can decide to move from HDFS. So the bulk input, you can decide to move into HDFS file system. You can also decide to move from HDFS into a relational database system. So depending on which direction that you want to go. So with Scoop, my PC is not responding. Okay, it's responding. So you might need to specify the destination directory on HDFS, how the data is terminated. This is for import when you are importing into a Hive database, and so on and so forth. There are so many commands. You can even create your own command if you so wish to do so. So this is what it looks like. But simple stuff. The commands that you need to learn, they are also very few. They are not a lot of them. So next is Zookeeper. And again, as I said, those guys, they just look around and they just look for a name and call a tool, letting it that they feel they want to call it. So Zookeeper, it's a coordinator. So within the Hadoop ecosystem, remember another tool that does almost the same function like Zookeeper is Yarn. Yarn is a coordinator, is a scheduler. It schedules who has access to a processor. It schedules who has access to memory at any particular point in time, who has access to any particular resource. It tracks all the applications that are running within the core Hadoop framework, within the core system. It tracks everything that is running between MapReduce and ADFS. It tracks everything. But beyond the Yarn, you also have Zookeeper that also coordinates all elements within the distributed application. So now that we have extended the core components into Hive, into HBase, into Flume, into OZ, into Pig Latin, and into Scoop, then we are going to need a special kind of coordinator who is going to be coordinating all of those applications and the activity that is running within them. So Zookeeper coordinates from start to the end of multiple nodes in the cluster. It does process synchronization, it does configuration management, it does self-election. In case a particular leader. If in the cluster you can have the leader, the master in the cluster. If he goes down, it's zookeeper that automatically nominates. It's zookeeper that automatically nominates the application. It automatically nominates the next leader or the next component of the cluster that should be assigned as a leader. So that process is called self-election. It does configuration management where it sends configuration attributes of a particular application to the cluster. So if a memory is going to be needing a particular size of, if an application is going to be needing a particular size of memory, that configuration for that memory size is zookeeper that does all of that configuration, and it ensures that there is consistency in those configurations. It does process synchronization. Process synchronization, what it means in layman terms is that you have different applications that are running. At what time is this application needs to run? At what time is it supposed to exit so that the next application runs? Zookeeper does all of those process synchronization, and it does it seamlessly and transparently from the user. You can see it's all this stuff. They are simple stuff that you just need to understand what they do. We are still doing the introduction to into big data and the tools for handling big data. From next week, I'm going to be handing over to other tutors from next week. I'll be handing over to other tutors who that will take us through the analytical tools and R programming and the other aspect of this course. So my job is just to do the intro, and once we are done with the intro, then I hand over to the guys that have more technical knowledge than I. So they'll start with the understanding of analytics or understanding of data engineering, and then they take it on from there. Prepare to do a lot of programming, prepare to do a lot of practical hands-on session with them when that time comes. It was only last week that we did practical hands-on sessions for this class. But with them, it's probably going to be almost every class day that we're having those sessions. Okay, so Flume, it also does almost the same job as School, but it's used for transferring large amount of data across different data sources, from different data sources to a single centralized database. So when you want to move data from multiple sources to a single database, Flume is your go-to guy. So what Scoop does, Scoop is peer-to-peer. I want to move from Oracle to HDFS, go to Scoop. I want to move from say Hive to Oracle. Scoop is going to get it done. But when you need to move across multiple and different data sources into a single centralized database, Flume is the go-to guy, and it's reliable and it's able to collect and assemble and move data very, 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 very fast. It is popular. It's popular for moving streaming data when data is streaming. So you can see the type of data that you find on platforms like Twitter, for instance. Those are streaming data that are changing almost at real time, or email data, or maybe data from social media network like maybe Facebook. Those type of data, they are streaming data. So if you want to move massive amount of data from those data sources, from multiple sources into a single centralized location, Flume is the guy that can get that done for you. I can get it done seamlessly. You can get it done seamlessly. Then you have OZ. OZ, I think I explained OZ to you. It's a workflow. I'm going to explain what it does. Example of workflow. workflow. I'll just type workflow. I'll show you. So this is like a workflow. Yes, I think I have some workflow here. What's that stuff called? It's called 9. Okay, so 9.exe. Okay, so let's hope this comes up before the end of the class. So I'm going to show you some workflow. So what OZA does is that it provides like a GUI interface, like a graphical user interface for defining workflow. So you have a lot of job to do. You want to move data from HDFS, load it into Hive. After loading it into Hive, then you want to run some maybe pig command on those data that is loaded into Hive, and then call maybe Scoop, and then call Scoop to extract that data from Hive and load it into another location. And you want to like create all of this process in a sequential order in such a way that you don't need to be monitoring it. You just want to automate it in a way that it runs easily with minimal interaction from you. You can use OZA to create an open source workflow that coordinates all of this data processing, this data processing job. So the way it works is so you can define the different workflows from start to finish, and then you just need to click on the beginning. Once you click on the start, then it runs that job from the beginning to the end. So let me launch this, and I'll show you what the workflow looks like. So Hadoop also have its own workflow functionality that coordinates job. It has two core components. That is the workflow engine and the coordinator engine. The workflow engine stores and runs workflow composed of different type of Hadoop job. Maybe it's MapReduce job, or Hive job, or Scoop job, or Hive job. It's the workflow engine that stores and runs all of those workflow. While the coordinator engine runs the workflow job based on the predefined schedule. So you can schedule a job that I want a job to run by 2 a.m. Is the coordinator that makes sure that that job runs at that particular 2 a.m. While workflow makes sure that it stores and runs the job. The coordinator makes sure that it runs at the time that it has specified that it must run. So this is an example of a workflow. Okay, I think this is still coming up. I'm going to show you this workflow. This is very, very important. I'm going to show you this workflow, and I'm also going to stop on this note. But let me quickly show you a workflow from 9. 9 is a data analytics tool like Microsoft Azure, like ML Studio, like SAS Enterprise Miner, like Oracle Data Integrator. 9 is another tool that has that kind of a workflow, and I hope it comes up. Okay, so I'll show you a workflow. Let me see, where do I find? Let me look for the workflow. Okay, it's coming up. Okay, so let's look for a very common example. Enterprise application. Let me see, analytics. Let's go to analytics. And under analytics, let's look for scoring, classification. Where's classification? Okay, classification. Yes, classification. So let's look at this. So if you look at this, I'll show you a workflow. So this is a workflow, and this workflow is defining a predictive modeling job. So this table reader goes to a table, maybe a Hive table, to go and read the data. After reading the data, this partitioning split the data that is read into a training set and test set. Then color manager codifies what we are trying to classify. Then decision tree learner tries to learn the distribution of data within the training set. Then you have the decision tree predictor. It tries to predict the test set based on what was learned from the decision tree. And then you have the scorer. Here is a workflow. This is not wrong. So you can just come to scorer and like click and execute. When you try to execute, see, it starts with, so it starts from the back, then it goes, then it ends here. So if you saw it, it started with table reading, partitioning, then it goes all the way to scorer. It did not execute all of them at once. So let me disconnect this. I'll disconnect this. Yes. Then I'll connect it again. So I'll connect it. So you can see everything is now red here. No, this is yellow, 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 yellow. So you can decide to run each of them one at a time, and run each of them one at a time, and run each of them one at a time. Or you can decide to go to the end and execute from this point. If you execute from this point, it runs it and it gets to the end. So this is like a workflow process. So you can automate this in such a way that at a particular time of the day, you want it to run only at 2 a.m. in the night when people are not connected to the data source. It's the workflow engine and the coordinator engine in the OZA system that manages the Hadoop workflow management. I think it's been a full day. Please, I'll be glad to take your questions. If there are no questions, we'll do some more demonstration. Tomorrow. Yeah, we'll do some more demonstration tomorrow, and then I will hand over to somebody else that takes over from me after that. So please feel free to ask your question if you have any question.
No question from
Okay, so I'm assuming there is no question. Okay, do you have a question? Emmanuel, Adebayo, Kola, it's been a while. You've not been coming to class. You are not a good student. Fatima, you have Dorcas, Temilade. This is a full Kola Wale. It's a full class today. Tell me, you joined the class very, very late. I was monitoring you because I wanted to call your name at some point. So in case you have any question, please feel free to ask me. If you remember to ask the question, you can ask me in the class tomorrow. Thank you for joining, and have a nice weekend and enjoy your Valentine.
Bless him.
Bye-bye. Okay, Kola, please go on, Kola.
Okay. Yeah, you mentioned that there will be splitting of the class, or there will be some people coming in. So I'm thinking, for the data engineering program, how does it work? Is it the same lecturers or a different set of lecturers?
It's a different lecturer that handles data engineering, and a different lecturer handles the data analytics class. So from next week, the data engineering guys are going to be in a separate class, while the data analytics people will be in a different class.
Okay. Secondly, please, I have the material. Maybe would I have wait for him so that he will guide me through the workbook? Because what I've noticed is that as I'm reading through the textbook, I'm reading book 1. A good number, of what we are learning, you are helping us to go into more detail and explain it better, because the literature can be challenging at times. For the workbook and practicing, would our lecturer be helping us, or how does it work?
So last week we had a lot of practical session. We had a lot of hands-on session last week.
Yes.
Friday last week, Saturday last week, it was pure practical that we did. You did not show up in that class. So it may be difficult for you to.
No, I was around on Saturday actually. I saw the practical, and I thought it was challenging for me to understand. But I saw how you navigated through the VMware and.
Okay, so great. But no problem. You can also visit the video again. But I'm sure there are going to be few people in your class, so you'll be able to have that one-on-one kind of interaction with your classmates. Don't worry, it's not going to be your next week.
Okay, thank you.
Okay, all right, everyone, take care and have a great evening. Bye.
Thank you very much, sir, for the wonderful lecture.